All right. I think here we are. Okay.
Yes.
So this question is about. Okay. Have you done this question?
Basically, this question I haven't done, but I know how I can done because I have seen that question in quiz too. They are explaining, so I thought I will do it. But
No.
basically, it's easy. Basically, we have to find like we have to make a matrix
Mhm.
for given condition like transitive closure.
Okay. Once again, let me just copy this to the place, and then we'll find out. Okay. So what is given in the question? Can you just read the question?
Yes, sir. If there is at least one path between vertex I to j, yeah, I equal j, then v square bracket I j equal to 1. Basically, v 0 0 1 0 1 like that.
Correct.
Otherwise, it's 0. Basically, if there is a age, if I to j, then it's come to 1. Otherwise, it becomes 0.
Correct.
Am I
Correct.
right?
Yes. Yes. Exactly. So if no, no, no. What did you say? If there is an edge, okay. If
From
there is an edge
I
from
to
I to
j,
J, mhm.
then it's come to be 1, right?
No, they are saying that path, not edge.
Yes, that means yeah, path. Yeah, I to j if there is a path exists, then you
Correct.
equal to 1. Otherwise,
There is a
0.
difference between path and edge, right? You know that.
Yes,
Okay. So fine. Let's say that we have no four cross four matrices, right? There's a we
yes.
have four vertices.
Four vertex, so four cross four. 0 1 2
Okay.
3.
Yeah, I'm not gonna put zero as of now.
Okay,
Tell me. So what is the
okay,
transitive closure for the given graph? Okay.
okay.
Fine. Okay. So we can see that if I equal to j, I mean, then it is one, correct?
Yes.
So that means all the
Or diagonals should be 1,
diagonals are one. Good. Okay. So then,
and it is also symmetric about diagonals, right? If because it become symmetric now about diagonal. No, no, no,
not
no,
sure.
no. Because it is undirectional.
Correct. So we can see that from zero you're able to reach. Okay, let's fill this matrix. Okay, from
Okay,
zero can
0
you reach
to
one?
1. Yes, we can reach 1.
We have a direct path. From zero can you reach two?
0 to yes.
Yes, we are
Sir,
able
I'm
to reach.
asking like it's necessary that we require to go from 0 to 2 in one step, yeah, multiple step.
No, no, no. They are saying that one path. Path doesn't mean
Okay,
that
oh, okay, at least
because
one path.
yeah, at least one path. You can take
At
many
least
steps.
one path means
Hmm.
we can go in any of the node, na? Like we
Yeah,
can go
any
0
different
to
way,
1.
you just need to go and finally reach it, reach that question. Okay,
Okay, yes.
good. Go ahead. So from zero to three,
And yes, we can go.
all right. From one to
And
zero,
1 to 0, 1 to 0, yes,
okay. So from one to two, two to zero, right? Yeah.
yes,
And from one to one is possible. So one to two,
yes. 1 to
okay.
2, yes.
One to three,
1 to 3, yes.
okay. So two to
And
zero,
now 2 to 0. 2 to 0. No. Yes, yes, we can go.
we
Like
have a direct,
2 to
direct.
0.
Yeah, we
Yes.
have a direct path, right? Two to zero. Go ahead. Yeah.
No, how sir to 2 to 0 direct path? Like we have to go first. Yeah, oh, 2 to 0, yes. 2 to 1.
Ah,
Yes, we can go 2 to 1 we also. 2 to 3. We can also go.
correct.
Okay,
So
now
three to
3 to
zero,
1. 3 to
three to
0. 3 to 0. No.
no, three to
3 to
one,
1. No.
three to two.
3 to 2. No.
So that's how. Just see if both the matrices are same. One, no, 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 no. Zero, one, right?
Yes. Yes,
So
sir.
this is how you do this question. Got it?
Okay.
Hope you're clear with that. Any doubts in this question?
No, sir.
Great. We'll go to the next question. So what is this Floyd-Warshall algorithm? Do you know about that?
So basically, today I have watched the quiz session division In that video I have learned like they are finding the shortest distance between every pair
Correct.
can be
All
anyone
pairs
like
shortest path. Yes. Detect whether the graph is have a negative cycle. We can also detect if there is any negative cycle or not. Okay.
negative cycle we can detect from the Floyd Versal algorithm.
Correct. Yes. And the
Okay,
question is, how can we use the Floyd-Washer algorithm for all the past shortest path to detect whether a graph has a negative cycle?
okay.
Okay. So, and what is it saying? So the answer is,
Say answer is second.
hmm. So
But
I to I,
just I
the first
also
option.
want to know.
Tell me
Just I want to know like why rest of three option is wrong.
why? Which option?
Three option is wrong except one
Yeah.
because
Third
I
option.
didn't know.
Yeah. Third option is wrong. When you have what you know. Okay.
Check if
So
any
how does
shortest
this?
path.
Correct. Correct. So when you have negative weights, it can reduce. Okay.
Negative
So
weights it can
correct.
reduce.
Correct. Yes. When
But
you
I
have
can
negative,
get you.
it can reduce. Okay. So how for the in order to know that you need to understand how the Floyd virtual algorithm works. Okay. Don't worry. Just give me like 5 minutes. I'll just little bit touch you up. Right. Where is it? Here it is. Do we have a working of that? No, we don't have working of that. So let me open the slides. Shall I?
Yes, yes.
It might be helpful for you. That's why. It's from week 5. Make sure you understand the concepts. So once you understand, it is easy for you to remember.
Okay.
Right. If you don't understand, it's a problem. So where are we? Floyd version. Right. Hey, this is nice. Look at this. Every time the color changes. Every time it rotates.
Okay. Yes.
Well,
So have you recorded like back to week say week 6, week 7, and week 8 graded assignment?
yeah, yeah, we did.
You have recorded all these things
Yeah, it's
present in
there.
YouTube.
Yeah, it's there. It's there.
Okay, so it's a good for practice.
What? Repeat.
I'm trying to say like it's good for practice. That if a video are already there, so I can
Correct.
watch all the video.
Yes, yes.
Will
It'll
helpful
be
me.
anyhow coming from the straight. Yeah. Okay. So this is how Floyd Washer algorithm will work. Okay. During the
Yes.
first iteration, what are you doing?
Basically, if there is a age, then we put its a weight. Otherwise, we put infinite.
Correct.
If
So
if
from
if
zero to
zero
one.
to yes,
Huh,
from starting we start from 0 to 1, 2, 3, 4, 5, 6, 7, 8 in first
correct.
iteration.
Uh-huh. Very good. So you're already understanding that. Very nice. So now that you have understood it, it's easy. It's going to be easy for me. Okay. So I'll come here. Okay. So what is this saying? So check if any shortest path entry a of I to j reduces from one iteration to the next. Okay. So during the first iteration, what is the shortest path to reach one?
Reach one from
From
which
zero.
node, sir?
From zero.
From zero only 10.
Correct.
Not
Yeah.
no, sir. How
Yes.
we can say like if we go from 0 to 7, 7 to 1, 1 to
I'm saying.
7 to
I'm
6, 6.
saying during the SP0 first iteration.
Okay, 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 sir. Yes,
First
10, 10
iteration. This is what you have. So what is the shortest path to reach one from zero?
is 10.
Sorry, zero. I mean from
0
zero
to
to
0
one.
to 1
Correct.
is
So it
10.
is 10, right? So during the second
Yes,
iteration, you will look into two paths, right?
1. Yes.
Okay, second, third iteration. Some iterations are going. Okay, but if you see, one, two, third iteration, I think, right? So you can clearly see that from here to here you can come again. 7 to 6 you can come, and from 6 to 1 if you go, it is gonna reduce. right? So now
Yes.
what is the, if you go through this cycle, what is the, what is it?
Minimum path.
Shortest path?
Minimum
Tell me.
are 8 and 1 9. 9 minus 4 5. I
Correct.
think 5.
So you're clearly able to see from one iteration to another iteration, there is a reduction in the shortest path, right?
Yes. Yes.
Okay, so this is possible. Uh, what? This is how it is going to be. So um, this is valid, right? Still, it is the shortest path, correct? Does
Yes.
this mean that there is a negative cycle? Is this cycle negative?
No.
No, right? So if there is a negative cycle, if suppose you have a negative cycle,
Like
what is
if
negative? Tell
negative
me.
cycle is basically if you reach from if you start from one node to last node, if
Mhm.
at that base should become in the negative number,
Correct. Okay.
then it become
Starting
negative
from,
cycle.
yeah. So starting from zero, if you come back to zero, the total
Yes.
weight will be negative,
Yes.
right? So if you have like that, so what will happen every time you, so initially shortest path to zero will be zero, correct?
Zero.
So let's say like that, okay, or infinity we can
Yes,
say.
sir.
Okay.
Yes, sir.
So after you're done with the cycles or whatever it is, okay. So what will
After
happen?
one I
So it will reduce after one cycle is done. It will reduce to -1, for example.
yes.
Okay.
Now
So
after that it become -2.
correct. -2, -3. So infinity, it will go to minus infinity,
Yes.
right? So which is, that is why it is saying that it should not have negative cycle. If there is a negative
Okay.
cycle, the value will reduce.
Okay.
Okay. How will you identify that negative cycle? During the last iteration, they will talk about it. Give me 1 second. Correct. So where have they mentioned it? Have they mentioned it?
I don't know, sir.
Searching for it. Yeah. So non-negative, like words with negative edge weight, assuming no negative cycles are there. So if a negative cycle is there, so after the last iteration, um, I'll tell you. Okay. Okay. So this is all past shortest path, right? So I'm
Yes.
gonna reduce this size, and then I'll draw here. Okay. So let's say that you have A, B, C, mm, D, and E. Okay.
Yes.
Okay. So let's say that from A to B, B to C. Okay. So this is how the edge is. Okay. And let's say that there is another path like this. From D you can go here. C also you can go. Okay.
Okay.
So let's say that if I put this is like 100. Okay. From B to D it is like 1000. For example, I'm giving. Okay. So this is 200. Okay. So then this should come as negative. So I'll put like minus 1000 minus 100. Okay.
Yes.
Tell me shortest path from A to E. Can you tell me what is shortest path? Shortest distance
A A to E. Okay.
A to B. Yeah, I'm asking you what is A to E.
Okay. So A B A C C D E. So
Correct.
if I calculate, and it will come in negative form, right?
Correct.
800 minus 800,
How?
because if we go A to
So
B,
let's consider.
100.
Let's consider that. Wait, 1 second. Let's consider that there is no path here. Okay. From C to D also
Okay.
you can't come back.
Okay.
Now you tell. See, this is a cycle. This is a cycle, right?
Yes.
And this is the negative cycle. Yes or no?
Yes, it's a negative cycle.
Very good. Go ahead.
So A to B, B to D, D to E. So it come to 14, 104,000, right? But it is a max, not
So wait a
maximum.
minute,
It is
100,
a
wait, 100, 1,000, 11, and 12, 13, 1,300,
yeah.
right?
Oh, sorry. Oh, 13.
You
Yes.
forgot some. Yeah. So it's ABDE. If you come in ABDE, it's 1,300, right?
Okay.
1,300. But if you see, maybe after four iterations, it will come like that. So if you see A to B, B to D, again D to C, D, and then you come back here. So now I'm saying
Yes.
A, B, D, C, B, E. Okay, so let's say that this is going to be the petrol cost or diesel cost.
Okay.
You remember, sir used to tell a scenario, right? So let's say you're a taxi driver, okay, and
Yes.
you want to reduce the expenses for the petrol.
Okay.
Okay, so if you come from A to B, you will spend 100 rupees. Okay. B to
Yes.
D, you will spend 1,000 rupees. But if you are going from D to C, now you will gain 1,000 rupees.
Yes.
Okay, so this is like another 100 rupees. If you go from B to C, you're taking customers coming along with you, right? So you're gaining some more money, right?
Yes, sir.
So now you tell me. Now do you understand what is happening here?
Sir, basically it's become negative now when we moving in the loop, like
Correct. When
reduce the
you move in
cost
the
is
loop, yes. When you move in the loop, so if you are going A, B, D, C, E, so A to B is 100, 100 plus 1,000
thousand
plus
minus.
D to C, minus, right? Yeah. D to C is minus 1,000. Go ahead.
Yes, and minus 100.
C to B is minus 100. Okay. Now
Yes,
B to
B2
B, then
and
D to
B.
sorry, B to D,
Yes,
then G. Yeah. So what is B to D
then
is plus 1,000.
yes,
Okay. Then plus 200. Now if you sum it up, what are we getting? So plus 1,000 minus 1,000 can be cancelled.
and
So
100
now,
also can.
yeah, 100 gets cancelled. Now how much is the sum? It is 1,200. So
Yes,
what it means is that if I take a different path, A, B, D, C, B, D, E, so it is going to be 1,200.
yes,
This is for one cycle, right? For one cycle, you are reducing 100 rupees. What if I do like 100 cycle, or let's say 10 cycles, right? Every time you go to this path, it keeps on reducing, right? It doesn't come to an end.
yes,
So that is how you are gonna, you know, you have like how many? One, two, three, four, five. You have like five different vertices, correct?
yes,
Okay, in this case, you have seven vertices. That means you will go till eight iterations.
yes,
Okay, see, for the eighth iteration, you don't have any change. See this, the last, not just that, but you will be able to see that there is no changes. So you understand the concept here? How you are finding out the
yes,
negative weights?
yes, sir, yes, sir. Negative weight I know how to find.
Correct. So now coming to this question here, do you have any doubt? You want to ask anything now?
No, no, I don't have to ask like.
Okay, fine. So coming back to this question, so if any shortest path A of I to J reduces from one iteration to the next cycle, it doesn't mean that. It just means that it has negative edge, right?
Yes, yes,
We saw that in the picture also. It just has a negative edge. It doesn't mean that it is a negative cycle. So this option is wrong. You got the point,
yes,
right? So this option is also wrong. We can detect negative cycle. We just know that, right? So and look at this. A of I to J is negative, which is wrong. Correct. No?
if any shortest path entry AIG is negative.
Hmm.
No, I think yeah, it's definitely no.
Yeah,
Wrong.
it can be negative. See, at the last iteration, you have from 6 to 1, it is what is the shortest path? It is minus 4.
Yes,
It doesn't mean that it is having a negative cycle. Correct.
yes, sir.
Okay, good. So you got the answer why it is?
Yes, I got it.
Very good. So shall we go to the next question or you want to ask something else?
No, no. Next question.
Great. Sorry, this is mad too. Right? Here we are. Hmm. So What is this question about?
Behavior.
Hmm? Suppose we have
Sup-
unweighted
be,
graph
yes.
with a negative weight cycle, undirected graph with a negative weight cycle. Okay, there is a negative cycle there. Okay, which of the
Yes, sir.
following is correct? Kruskal, Prince,
For negative weight cycle, I think, sir, for algorithm, which one
hmm,
is correct?
correct.
Kruskal algorithm and prime algorithm can be used to compute the minimum cost spanning tree.
Hmm?
Just let me, sir. Thank you. Basically, I have written make a notes. Just I have to see. Like,
Repeat. What did you say?
basically, Dijkstra algorithm is not using for negative weight cycle, right?
Mm-hmm.
So, Kruskal algorithm. Sir, basically, yeah, we can use both of the cycle, na, for finding like minimum spanning course of tree. We can use sir both
Yeah, we can use both.
because it's a theoretical portion. Like in the theory portion, they have written like we can use to compute.
Okay. So we know that, right?
Yes.
Hmm. Okay, fine. Uh,
Yeah. In fourth, sir, I have doubt like sir why VFS become Dijkstra algorithm when its weights are equal.
hmm. Okay. Okay. Fourth question, right?
Yes.
Okay. So let me read the question here. We can use BFS instead of Dijkstra's algorithm to find the shortest path from the given source node to every other node. Okay. So what is your doubt here?
So basically, my doubt is, so why BFS work? BFS can we find two shortest path when weights are equal and weights are not equal? By VFS is not working.
Why Dijkstra's is working
Basically,
and why? Tell me.
basically, sir, weight of edges if equal, then BFS is work, right? So just I
Correct.
want to know if weights are not equal, then why BFS is not working?
Okay. Fine. So let me just show you an example. Hope you saw the question there. Okay. A.
Yes, yes,
BFS. Okay.
yes.
Then D. Okay. Then I have E. Okay. The question is to find out the shortest path from the given source. Then I'm going to give from here. Right. One more. Right.
Yes.
Okay. So let me give you the weights. Basically, I'll take 10. If we have more range, then we can easily re-alter 10, and then can give. I'll give 10 only. All 10. 9, and then I shall give 10 here. Okay.
Okay.
So what is BFS?
So BFS is basically it's explore to its nearer first adjacent. We can say adjacent.
So can you just draw the BFS for this?
BFS. Okay. So
Let's take,
basically,
B comes first. All right. Let's take like that. Shortest. You will explore the shortest if both in the BFS. Okay.
yes.
Okay. C. Okay. This is done, right?
ABC. Yes.
Mhm. Then, so for A
Then
we have explored both. Then for B we'll explore. So B
Yes.
is connected with E, right? For now C we will explore. C is
C is
having,
yes, C is
yeah,
having E and D.
yeah, D. D is already explored, right? We don't need to worry about that.
Okay, yes, yes. That's already explored.
Okay. So this is for
BFS.
BFS. Right. So let's go to Dijkstra's. Okay. So tell me,
Yes.
according to the Dijkstra's algorithm, um,
First, we
how will
takes
you
a
find out the weights?
minimum for if we are starting like from vertex A, then we have to take a minimum uh, weightage, right? So it's equal, so we can take anyone like A to B.
Tell me. Okay. I also want add one more edge here. Okay. This edge is of weight 100. Okay.
100. Okay. So we have, sir, we have three. We have from
So
A.
that
We
means
can go.
I, that
Yes.
means our BFS will change, right?
Yes.
Okay.
BFS is basically A to.
Huh?
Uh,
A
so now BFS, how BFS is work, like we have three
A
neighbors.
A to
So
B, B to, I mean, then A. Yeah, same thing. A to B, then A to C, and then what is the other direct edge? You have another E,
okay,
right?
okay, yes, okay,
E.
yes.
Now this E will be erased. Okay. So now what is next? So now you will explore B. Now tell me,
Now
C is
B
already
to,
explored.
yes, C is already explored. Now coming to C, uh, D,
C is
C to
okay.
D.
So you get D, right?
Yes,
So this is saying that if you start from A, right? So A, you
yes,
have the shortest path. Like from A, you can directly reach E, right?
yes.
In one step. So from A, you can directly reach C. A, you can directly reach B, and then if you want to reach D, A to C, and then C to D, right?
Okay.
So this is what it is telling. This is for unweighted. Okay. So if you do the Dijkstra's algorithm, what will happen? Tell me. You're starting from A.
Yes, A. Then we have to explore. It's sorry. Then we have to go. It's adjacent, which having lowest weight, right? So we can go if it is equal. Then we can go anyone. Like
Let
we
me
can
also
go
let me
A.
also let me also put the weights here. Okay, 10, A to C 10, A to E it's 100, right? And A
Yeah.
to and C to D it is 10, right?
Oh,
So which
okay.
means, so if you want shortest path for A E, it is 100. That is what DFS is saying,
Yes.
right? So then A C, the shortest path is what? A B, it is 10 from A D. It is 20. This is what BFS is saying. Now tell me Dijkstra's algorithm for
So
AB.
A B. Now A B, and then we have option again a minimum. So we can go A to B, B to E.
Correct. So let's go for AC. AC is again 10, right? And then now we
Okay.
go to AD. If you want to
No.
go to AD, it is 20, right? But
A
for
D.
AE,
Yes.
yeah, for AE you can reach in 20,
Yes.
right? But if you see, and then if you have 9 here,
C
you have
E.
9 here. So
Then
ACE
19.
will, yeah, 19
19.
actually,
19.
right? So
Yes.
you got the point. So but when you have all the weights are equal, okay, A B, C B D, then E, okay, then this is also 10,
Yes.
okay, and so all the edges, we are telling that all the edges are basically same weight. If I need to draw the
Yes.
graph figure,
If we all weights are same, I think it becomes similar, right?
no, yeah, it becomes very similar to this, right?
Yes, sir.
Because in AE you can reach in just 10 steps, right? 100 will be replaced by 10. You
But
understanding
but
what I'm
but
saying?
but but tell me, sir, one thing. If we use BFS for equal weight, so for when we want to go A to E, we can go in one step, right?
Correct, exactly.
But when we use like uh, 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 what uh, what algorithm is
Dijkstra's.
digi-
Dijkstra's.
yeah, digest, so then
Whatever.
it means, sir, we can go A to C, C to E. It will come to na, sir.
Yes, that's right. But that is when you have unequal weights.
Okay, yeah, in equal weight we can go directly. Yes, yes, sir. We can go
All
directly
the
because we
weights
have
are equal.
option.
You can directly go to E, which is 10, right?
Okay.
Do you understand it?
Yes, sir.
A, B, then if you want, I'll just draw it once. 10. Then we have E, right? From we have one here. So in this case, we are just having 10 for all, right?
Yes.
So now draw the Dijkstra's algorithm for this. For A to B,
A
that's 10.
A to D is basically 20. A to okay, A to B 10, A to D 20, and A to C basically 20.
10, 10.
Sir,
A to B, you can directly come.
no, A to C how 10? Yes, oh, there is C. Okay, okay, okay. A to C is 10, and A to E is also 10.
Very good. Got the point?
Yes.
Hmm. So that is the reason. You I hope you understood it,
Yes, sir, I got it, sir.
right? And A to D is as usual 20 here, and even in BFS we got 20. Got the point?
Yes.
Very good. Just give me a second. I'll just take my charger. All right. Fine. So fourth question is done. Hope you understood that, right?
Yes.
We'll go to the fifth question. This is basically the concept. Just the concept. Clearing
Basically,
up.
50 it concept based, right?
Yeah, yeah. Which of the following statements are true? So we know that Dijkstra's algorithm doesn't work for the negative weights, right?
Yes, sir.
Why?
Because in negative bits it keep on decreasing at that node, sir. When you come in one time, its a value for example -5. When you come again, it become -10. It like that, its value basically keep on decreasing.
Correct. You're right.
That's why we didn't use for negative bits.
That's okay. So what about Prim's algorithm?
This algorithm is basically work for negative bits.
It will work. That's correct.
It will work.
So
Okay.
hence this option is wrong. I mean, so they are saying that doesn't work. Okay.
Yes, sir.
What about Floyd Warshall? Yeah, Floyd Warshall can detect
Can detect
negative signals.
negative bits, sir. It
Yeah,
should be
we saw
true,
that
no?
sometime back.
Yes, it should be true.
Mhm.
And
Works with negative weights but without negative cycle. This is also true, right?
negative cycle, yes.
It can it allows negative weight, but it's not allowing negative cycle.
Okay.
Hope this question is okay for you, right?
Yes, sir.
Okay, fine. Let's go to next question. Okay, ignore that. It's gonna like I just want to keep it very visible for you. Fine. So let's read this.
Okay.
Suppose
Yes.
read
Suppose
it.
we
You read.
run, yeah, suppose we run Prim's algorithm and Kruskal's algorithm on the graph G, and these two algorithms produce minimum cost spanning tree, TP and TK respectively. So
Hmm.
option one, TP may be different from TK if some pair of edges in G have same weight. Yeah,
Okay.
and second TP is always the same as TK if all edges in G have distinct weights.
Hmm. So the answer is like both are correct.
Yes, I think, sir. Basically, if same weight are there, so basically, minimum cost penalty can be different. Can be different. Like if the first
Correct.
option, according to first option, if same weight are there, then we have option na sir. Which one we have to choose. So according to this, minimum spanning tree become different,
Hmm.
but cost will be same overall, right?
Yes, yes. Minimum cost is going to be the same.
Yes, a tree can be different, but and second option, TP is always same as TA if all edges in G have distinct weights. Okay, TP is always the same as TA. TK if all edges in G have distinct weight. Sir, so can you take example? It's like why we become equal, like for
Sure, sure,
distinct.
sure.
I think, sir, I think if we do one logic, right, distinct means basically, I mean, cost should be minimum, right? Cost should be same
Distinct
from
means
both
all
sides.
will be different. All the weights are
No,
different.
no, weights are different. I know, but overall, when you calculate the is minimum spending cost, it come out to be same, na sir. Whether
Correct, correct, correct. You're right.
so that's
Let's
why
shall
for
we check that? Shall we check that?
yeah, yes, sir, yes, sir.
Let's take an example and do that. Yeah. Right, I'll have one more feature. Just give me a second. Hold on. Okay. So, okay. All right. Hey, I'll come back in a minute. Okay. I'm just need to go. I'll